Welcome back. And now in this example here, we're given the first term and we're given the common ratio, and they want us to give us the first 5 terms of the sequence. Okay, so if we just take the definition of a geometric sequence, then we know that it has to have the form of A1, right? So the first term followed by the first term times the common ratio, and then the first term times the common ratio squared, and then the first term times the common ratio cubed, and then the first term times the common ratio to the fourth, and so on, right? So if we want the first 5 terms, that's what we're going to do, okay? So if we get the first term, so we could do that by obviously the first term is going to be the first term, right? So A1 is equal to 5, and then A2, right, is going to equal A1 times R, which is going to be 5 times -2, which is going to be -10, right? And then A3 is going to be A1 times R cubed, which is going to be equal to 5 times -2 quantity squared, which is going to be equal to 5 times 4, which is equal to +20, okay? Now, by the way, the other way we could have gotten A3 is just to use A2, because A3 would be equal to what? A2 times R, right? If we use the recursive definition, right? So if we define this recursively, we know that every subsequent term is going to be a result of the previous term times R. Okay, so if we do, why am I doing that? That's A2 times R. So A2 is -10, right? So if we could do -10 times R, which is -2, we get the same answer, +20, okay? So then let's go to the next one. So A4, the fourth term, is going to equal A3 times R, which is going to be 20 times -2, which equals -40, right? And at this point you kind of see the pattern and you know what A5 will be, right? So it seems like it's doubling, right? Can't see A5. Let's go over here. So we went from 5 to -10 to +20 to -40, and this one will be +80.